Alright guys, so I'm working on the Hot Water 101. We still have the hum. We've replaced these. These are 40 at 150 volts, 40 at 450. And they were tied in down here. And I replaced them with these that are all 450 volt. So the way that they have it is those go negative, negative, and then negative over here. The schematic's kind of odd, but let's see here. So let's see if I can. So we have this here. These are the big ones on the top, 450 volt, 125. I ordered 150, 450 volt ones. So there's a 268 voltage secondary. And that goes out here to these 820 volt. It must be combining like that and that. So, I wish they wouldn't have put this thing crooked. It's hard for me to look at it. You guys can see it normal because I've got everything orientated. So the ones that we replaced today are going to be, so here's one of those, 125, 125. Those are the other two. So we replaced, that's the big one. And you can see that the negative side goes to ground. Okay, I'm just checking this because I was like looked at it and I'm like, I want to make sure all this looks right. Okay, so then the other ones, I don't know where that 20 is. Oh, I didn't pull 20s out of there. I pulled 40s. So somebody either changed it or Heathkit changed it. But they looked pretty normal to me. Yeah, anyway, these look like sprigs. Mexico! So, positive to ground, positive to ground. And then you have R7 in the middle. Okay, so, okay, we got a negative to the ground, positive to the ground. Some spider webs. So these caps here, right there, those four. What I'll do when I get everything, I'm just gonna disconnect them. And when I got diodes across them, so I'm just gonna disconnect them, and I'll leave them in here probably. And put the new small ones down in the bottom here. Maybe. It's going to be kind of a hassle with these because of the way they are. We got a lot of stuff in here to remove. It's not going to be as simple as I would like it to be. It looks like they use a ground tab. I've done it so long since I've done these. So you got one terminal there, really, and then the rest is on the can. So the problem is, I now have to deal with removing several things. I don't know why these ones are insulated and those ones are not. Anyway, this comes open pretty easily. So you can see down in there. I wonder I could probably just undo these. Alright, let's see here. I really don't like working on this kind of stuff very much. I just bump to the volume cord. Let me go ahead and undo that. I'm not saying I can't still get zapped, but you just undo it. So that's what it's going to look like inside of there. And these two are different. And 125 microfarad, 500 volt. It almost makes me wonder if somebody replaced these. But this is not the can. It says can negative. So basically, it's. So anyway, the manual. 500 volts DC, 120. The manual shows something less than that. It shows them, and it also shows them 120. I'm looking at it right here. 125, 450. 125, 450. These are 125, 500. And I was talking to my friend on the phone, and he explained to me how it works, like with different voltages and stuff, and how you could kind of check and get an idea. But in the parts list here, the so the output voltages of this is 820 volts DC no load, 700 volts at 250 milliamps. Ripple duty cycle. Out low voltage supply, high tap. Output voltage 350 volts, no load. 350 volts DC at 150 milliamps. Low voltage supply 275 volts, no load. 250 volts at 100 milliamps. Other voltages, negative 130 volts, negative 100 volts. Filament 12.6 volts, AC at 5.5 amps. Okay, so I'm looking here to see what the ratings were. It says 125 500 volt in the list, but in the schematic it says otherwise. It's kind of interesting. So it is what it is, right? Okay. I'm trying to look up something else really quick. So this other guy showing how to rebuild one of them. And he's explaining some things, but anyway, the high voltage circuit operates as a full wave voltage doubler driven by a separate 282 volt secondary by using a lower transformer voltage and then a voltage doubler. Less insulation is needed on the transformer. Okay. The output is taken across C1 and C2, which are in series, so the output voltage is 398 volts plus 796 volts. The effective output capacitance is something. So this guy, anyway, he's like some Dr. Greg Latta. I'm sure some of you have heard of him before. Anyway, he goes through a lot of really interesting information and talks about the bias voltage and the filament, and explains a lot of things. So he rebuilt one that was not actually the original. So he shows the same schematic they were showing. Now there are different versions of this power supply out there. There's different ones. So some of them have a different deal here. Okay, so what he recommended was ordering from Mauser. 150 microfarad 500 volt capacitors, 4 of them. 47 microfarad 450 volt, 1 required. 47 UF 160 volt, 2 required. And those are the ones I replaced, and I just used all of them. Now there are some other ones in the radio, I think, which might be worth dealing with. So let's see. So, let me. Do any of these feel warm? They don't. I almost want to say these might be good. I mean, I don't know. Because I think it's in the radio, to be honest. It just kind of sounds like it. And I haven't really noticed any erratic behavior. So, I'm going to go ahead and put the screws back in this, and we'll be back.